One part of stoichiometry calculations is something called limiting reactants. Before we see how it applies to chemistry, let's see if we can understand how sometimes processes are limited. So the example in your textbook talks about putting together some bicycles. So here we have, you go out to the garage or whatever and you have some things to make a bicycle. And you have 8 wheels, 4 bicycle frames, and 3 pedal assemblies. So that's what you're starting with. Like, it's kind of like your reactants. And you start to assemble the bicycles. And so what you can put together with what you have are 3 bicycles. So you have 3 complete bicycles. And then left over, you have still 2 wheels and a frame. And so the thing is, why do we have these things left over? And what limited or stopped us from making more bicycles? And if you look, we only have 3 pedals assemblies. So this was limiting to us, right? The bicycle making stopped because we only had 3 pedal assemblies. So you could only make 3 bicycles. Once you ran out of pedal assemblies, nothing else could happen and the rest was just left over. We call this being in excess. It was extra parts for our bicycles. So the same thing can happen in chemical reactions. So you can start out with a certain amount of reactants, and once one of the reactants is completely used up, the reaction will stop. The first reactant to get used up is what we call the limiting reactant, and the reactant that's left over when the reaction is complete is called the excess reactant. Stoichiometry problems help us figure out what's the limiting reactant, what's the excess reactant, and how much we would expect to make. So here's our first problem, and we've been starting with our balanced chemical equation. By this point, hopefully you've watched the videos on mole ratios, mole to mole problems, mole to gram problems, and gram to gram problems. We have to use those basic foundations to solve these problems. So here, when we're looking at our problem, we're looking at what we're given. So it says I have 0.25 moles of P4 and 1.2 moles of Cl2, and then ask me how many moles of PCl3 can I make. So what's different about this problem? Well, the first thing I notice is they've given me 2 things. I've been giving 0.25 moles of the P4, and 1.2 moles of the chlorine. And what they're wanting me to find is the PCl3, and in this case it's moles. So one of the first indications that you're dealing with a limiting reactant problem will be that they've given you both the reactants. So you know how much of each reactant you're starting with. Now there's multiple ways to solve these problems, and what I've found, something that's logical to me, is what I will do is I'm going to take the moles of this and see how many moles of PCl3 it will make. And I'm going to start with the moles of chlorine and see how many moles of PCl it will make, and then I'm going to compare my answers. So I'm really going to do 2 separate stoichiometry problems and compare the results. Now, by this point, hopefully you know that if you're going from moles to moles, that's a one-step problem that only involves the ratio. Moles to moles, 1 step. So I'm just going to do first, I'll start with the P4. So I start with what I'm given. And since it's moles to moles, I'll just multiply by the ratio. Whatever you're given, that goes on the bottom, and the P4 has a 1 in front of it. And then the PCl3 is what I'm looking for, and it has a 4 in front. Oops. Sorry. Moles PCl3. So that cancels. And so I get a 1 mole of PCl3. So if I start with P4, I get 1 mole of PCl3. All right, so let me do the second one, and I'll start with the chlorine. So they give me 1.2 moles of chlorine, And again, I'm going to try to find out how much PCl3 I need. So on the chlorine, it has a 6 in front of it. Since it's mole to mole, I'll just multiply by the ratio. That goes on the bottom. And then the PCl3 has a 4 in front of it. That cancels out here. So then I'll say 1.2 times 4 divided by 6. And I get 0.8 moles of PCl3. And I guess it would be 0.80 if I wanted to do correct significant figures, which is always my goal. All right, so here's the thing. So now I've compared, I've figured out, looking over here, I figured out, given the amounts I have, this is how much I could possibly make. Well, here's the thing. Remember, when one reactant runs out, then the reaction stops. But by comparing, I know which one is going to run out. It's going to be the chlorine. The one that produces the smallest amount, that actually is going to be our answer. Because once I get to 0.8 moles of PCl3, the chlorine is gone and the reaction will stop. So when I look at my question, it asks how many moles of PCl3 are produced. You're always going to pick the smaller of the two when you compare. So the answer is I'm going to produce 0.8 moles of PCl3. Now, what it tells me, whichever reactant produces the smaller amount, that is the limiting reactant. Because once it hits 0.8 moles, it's going to be gone. And then the other one, the P4, is excess. And the one that's in excess will remain in the container. Now sometimes it asks how much remains, and I have problems in the class lessons that go over those particular examples. In this particular video, I want to get the conceptual idea of limiting reactant. So I have two more problems, and remember you can pause at any point if you want to try to do some of the work on your own and then compare. So I'm using the same equation, but this time I'm going from different units so we can continue to practice our variety of stoichiometry problems. So in this problem, again, we read a question. So it says we have 20.5 grams of P4. So it says I have 20.5 grams and 20.5 grams of Cl2. So right away I know, okay, this is a limiting reactant problem because they've given me the quantities of both reactants. And what they want me to find is PCl3 in moles. Now I've included the molar masses on all of these different things because if we need them, it's there, and at this point that's not the main focus of what we're trying to do. So remember, I'm going to set up two equations with both reactants and decide how much of the PCl3 in moles are produced. Now, given grams, to go to moles, this is two steps. My first step is going to be to convert grams to moles, and then the second step is going to be to go from moles to moles. So I'm just going to start with the P4 just because it's first there. So I have the P4, and my first step is to convert that into moles by dividing by the molar mass. So if I say 20.5 divided by 123.88, I get 0.165. 6.548. That's moles of P4. And then I want to find out moles of PCl3. So then the second step, and remember, if you would like to do continuous problems, you just won't get the answer here. And on other videos I've showed continuous. I'm just trying to show step by step in this series, but on the class lessons, majority of those problems I will do is continuous. So I have both examples in the work that you can do. So we go from moles to moles of PCl3. We're going to use the ratio. And so let's see, P4 has a 1 in front of it. And then there's a 4 here. So I'm going to multiply by 4. And I get 0. Let's go to 3 significant figures, 662 moles of PCl3. Okay, so that's P4, and I'm going to change colors because it will all kind of start to blend together. So then I'm also going to compare to what if I start with Cl2, because remember, these are limiting reactant problems, and how I know that is they've given me both amounts. So they gave me 20.5 Cl2. I can't use the ratio when I have grams, so I'll use the molar mass, which I've already calculated for you and written above each of the substances. So I will take 20.5 divided by 70.90, and I get 0.2891 moles of chlorine. And then I'm going to take that, and I want to find out the moles of PCl3. So I'm going to, let's see, chlorine has a 6 in front of it, and the PCl3 has a 4. So I'll multiply by the ratio. The chlorine cancels, and so it's that, the 0.28 number multiplied by 4 divided by 6, and I get 0.193 moles PCl3. Okay, so now the idea is what you've done, and again, there's different ways you can do this. So if you watch the video online and they approach it slightly differently, that's fine. But what I like to do is calculate how much I need of how much each would make, and then I compare these two answers right here. The answer will always be the smaller of the two amounts. So this is my answer, and then that one that produces that, in this case, the Cl2 is the limiting, and the one that produces more is the excess. This right here is not really an answer, okay? It's just what I have to do when you have limiting reactants. At some point you have to compare, so I have to have both numbers so I can compare. The number that's smaller is always actually the answer. The other number is not an answer. It's just something I had to do to determine my answer. Okay, so the 0.193 moles of PCl3 would be what my answer would be. And I have one more of these problems. Again, I was trying to do a little bit of variety in terms of how many steps were required for each one. So let's go ahead and take a look at this one. So I see that I'm given 55 grams of chlorine. So I have 55 grams, and they're reacted with 25 grams of P4, 25 grams. In this case, they want to know how many grams of PCl3. So first I think to myself, all right, so for grams to grams, I'm going to need 3 steps. So I'll have to use the molar mass to convert from grams to moles. Then I'll use the ratio, and that will convert into moles. And then the molar mass again to convert from moles to grams. So it's going to require 3 steps to get my answer. I know it's a limiting reactant problem because they gave me the amounts of both reactants. So I'm going to get, I'm going to start with both of them and figure out how much each one of them would make, and then compare my answer. So I'll just start with P4, It's 25 grams. I'm going to divide by the molar mass, which I've already calculated here for us. And this is P4. And so that's going to give me a 20. I'm going to divide, first step, I'm going to divide by the molar mass. And that gives me the moles of P4. Then I'm going to take the moles of P4 and I'm going to multiply by the ratio. I'm going to keep writing because I'll run out of room. So the P4 has a 1 in front of it, so I put that on the bottom. And this has a 4, so I'll put the 4 on the top. That's the second step. So I'm going to multiply by 4, and I get 0.807, and this is moles of PCl3. And so then to go from moles to grams, I have to multiply by the molar mass of PCl3, which I have written above it. I calculated that for us before we started. So I'm going to multiply by the molar mass this time because I've got to cancel out moles. And I get to 110.84 grams, so it would be 110 grams PCl3. Okay, now I'm going to choose a different color to work with because I'm going to compare my two answers. So that's how much 25 grams would make. So now let's do Cl2. This time they gave me 55 grams. So I'm going to first divide. If you look, it's going to be a similar pattern. Divide by the molar mass to determine the moles of Cl2. And I get 0.7757 moles of Cl2. Then I'm going to multiply by the ratio in order to find moles of PCl3. So let's see, I have Cl2 has a 6 in front of it. That will cancel those out, and then a 4. So times 4 divided by 6. And I'm just going to write it down here. I get 0.517 moles of PCl3. And now I'm going to multiply it by the molar mass of PCl3 to figure out the grams, which is what we want. And I get 71.016 grams. So that's just 71 grams. Okay, so again, and this is a little ironic, every example which wasn't intentional, the one you're going to compare these two answers, and the one that is the least, that is your answer. This is not an answer. So it's 71 grams of PCl3. The one that makes that amount is called the limiting reactant, and the one that makes the extra amount is called the excess reactant. Now, if you want to see more problems like this, you can go on. There's a couple more problems under class lessons, as well as a problem that goes into how you would solve and figure out how much of the other things are left over. So there's more videos online under class lessons to help you with this.